This video is sponsored by Anaconda. Okay, so I posted a reel on Instagram last week covering the 3 top skills that you should include in your data analytics portfolio. And many of you asked for tutorials on how you can get started to clean, analyze, and visualize data, and I thought, why not making one myself? So in today's video, we are going to do a very quick, under 10 minutes exploratory data analysis project that you can follow step by step. This video will have an emphasis on how you can brainstorm realistic business questions based on the data, how to apply a user-centric product mindset along with some coding in Python. You can also apply the same logic to recreate similar projects using different datasets. And if you're looking for more of a data scientist position, you can include this in your portfolio as a simple project. If you're looking for a data analyst or business analyst position, you can definitely include this as more of a coding-intensive advanced data analysis project. We're going to use popular Python libraries such as Pandas, seaborn, and folium. As for your coding IDE, I tried to make this project as beginner-friendly as possible. We're going to use Jupyter Notebook hosted in Anaconda's cloud environment. This is free to use and super beginner-friendly. You don't have to worry about downloading the IDE locally or setting up a virtual environment to manage your packages. Everything is right there for you in the web browser, and we'll get to that step in just a minute. Okay, let's get started with our project. And the first step is downloading data. The data we're using today is the NYC Citi bike trip data. It is available on Kaggle, but I also uploaded it to my GitHub page for easy access through code. Both links are in the description box below. The original data has more than 1 million rows and 200 megabytes in size. For the purpose of this analysis project, we're not building any large-size machine learning models, so the same code can be applied to 20 or 20,000 rows. I did some pre-processing and included only data from October 1st, which ended up being around 40,000 rows and 6 megabytes in size. So check out the Kaggle page for the full data if you're interested, but if you're just following along, using the GitHub data should be more than enough. According to Wikipedia, it's an approach of analyzing datasets to summarize their main characteristics, often using statistical graphics and other data visualization methods. Essentially, there are 2 main purposes for an EDA. One is to clean your dataset to make it usable for the modeling stage. It is highly likely in a scenario outside of your typical school environment that your data contain missing value or certain columns need to be transformed to be specific formats, or you need to remove outliers, etc. The EDA stage of a project is where you will be doing these steps. The second main purpose is to understand your data better. Think of this as a brainstorming stage. You're asking yourself questions like, what questions are you able to answer with this data set? What models can you build based on the data that you have? Do you have enough data for a large-scale machine learning model? What insights can you already extract from the dataset without a formal model? What data visualization tools can you use to showcase these findings to business stakeholders? So let's take a look at our data. We have 15 columns available that can be summarized in 2 categories, trip information and user information. For trip information, we know how long each rental trip is in seconds. We have information on the location and names of bike stations where the trip started and where the trip ended, as well as which bike was taken. For user, we know whether the person is an annual subscriber or a pass holder. Given they're an annual subscriber, we also have information on their age and gender. Okay, lots of information to think about here. Let's do some quick brainstorming. What are some of the questions that we can get answers from this dataset? On a very basic level, we can ask how many trips were there in total. The title of the dataset indicates the data ranges from October 1st to the 31st in 2013. Can we verify this from checking the data? If you are the decision makers at Citi Bike Department, you might want to understand where these bike trips are taking place, who are using them and when, who are the repeating users, when does the conversion happen, in order to better allocate resources and boost ridership if that is your goal. There are other questions like where are the most popular bike stations for borrowing bikes? Perhaps a prediction model could help ahead of demand with making sure that everyone who wants to borrow a bike at every station has access to one. What about the popular stations for returning bikes? If we're thinking from a product perspective, focusing on the end user, we don't want someone who is borrowing a bike to get to work in the morning, end up having to return his bike 20 minutes away from his work just because the bike station that is closer is full. Because we know if this happens, the person is less likely to use the service again, and if this happens on a bigger scale, our user retention rate will drop. Although this is a toy project, these are some of the real business questions that you can ask yourself and get answers from real-world dataset. Especially if you have no industry experience yet, trying to put yourself in the shoes of someone who is in the role can definitely help showcase your skills to your potential employer. Let's take a deep dive into this dataset and start coding. Okay, I am already in the Jupyter Notebook environment. You can go to this notebook by typing mb.anaconda.cloud in your browser. As you can see, I've already done this project once. I don't want to make this video as long as how much time I spent doing it in the first place. So I'm just going to create a new notebook. The very first step is to import our packages. We need Pandas for data wrangling and seaborn for data visualizations. Next, we'll need to grab our data from the GitHub page. This link is also in the description box below, so if you want to copy that. Before we proceed to answer any questions, we are going to just quickly look at what this data is all about. The head function returns the first 5 rows of our dataset. This is useful if you want to see some example values for each column. So for example, trip duration, we can clearly see they're in seconds, start time and stop time. I think they're both in string formats, but they include the year, month, day, as well as hour, minute, and seconds. We have the trip start station ID, station name, station latitude and longitude, end station ID, name, latitude, and longitude, bike ID in integers, user type, birth year, and gender. df.shape will return the number of rows and columns that we have. So we have 15 columns here and about 40,000 rows. df.columns returns the column headers. And if we want to get a statistical summary of all the numerical variables in this dataset, we can use df.describe. The summary for some of the columns are more important and valuable than the others. For trip duration, we have total 40,000 rows. There is a mean of 822 seconds. So we know on average, these trips take around about 10 minutes, 10 to 12 minutes, with a standard deviation of another 10 minutes. Minimum, these trips are 1 minute long. And then we have the distribution here for 25 percentile, 50 percentile, the medium trip duration, and max trip duration as well. Okay, so what if we want to look at the distribution for trip duration? We would, in this case, plot a histogram. And we can use the seaborn library histplot function. Here we have a histogram of trip duration. We can see most of them are near the 10-minute mark. But because the x-axis is showing all the way to 50,000 seconds, we can see there are some outliers. So next, I'm going to show you how to plot scatter plots for all of the trip variables. A very quick way to do this is the pair plot function in seaborn. I don't recommend doing this because it takes a long time to run and it returns a huge number of plots that you need. But if you just want to quickly look at the relationships among variables, I think this is a very efficient way to go. Okay, so just to show, this is what it looks like. It's a lot of information to take in. It might make more sense to first select the variables that you want to look at and then use this method on a subset of the data. So for example, if we want to look at just trip duration and gender, we can slice this data frame by column names, trip duration, and gender, and then return only these 2 variables. One more question that we're going to ask ourselves is what percentage of the users are subscribers? To do this, first we need to count the number of rows that are subscribers. So we're slicing the data by only selecting rows where user type equals to subscriber. And we're counting them. 37,000 rows are subscribers. We're going to name this num subscriber. Okay, so next step is to count the total number of rows that we have. And we can do this using length of the whole data set. Finally, to calculate the percentage, we're dividing the number of subscribers by the total number of users on October 1st. So num subscriber divided by total times 100. We have 92.03. We want to round this number to 2 for easy rating, applying the round function and then print. Okay, so now we can see 92.03% of total writers on October 1st, 2013 is annual subscribers. We're going to answer 2 questions in total for this project. The first one is to visualize the trip length with trip start time. We want to understand whether trip time varies based on what time of the day the trip starts. To do this, we need to first transform our trip start time column. So let's take a look at our data again. The way the start time is presented now, it's in a string format, but we only want the hour of the day. So we want to take a substring of start time column to only include essentially these 2 numbers, 0, 0. So that's the hour of the day. So what I did here was I used a lambda function to apply to every single row in this dataset. I have to admit, every time I use lambda, I have to look it up because I keep forgetting. But if you're more comfortable with a for loop or a while loop, that's totally fine too. I think lambda is more efficient when you're running large datasets, but if you're more comfortable with for or while loop, by all means. So we're slicing each cell in this start time column, and we're only taking the 2 characters that we want. Next, we're going to make this a new column called hour in our dataset. You can see now at the end of our dataset, we have our column. Next, let's visualize correlation. We're going to use the scatter plot from the seaborn library. Our x-axis is going to be hour, y is going to be trip duration, and data is our data frame. Okay, so from this data, we can tell during the early hours of day from midnight to 6 a.m. Most trips are very short, but during the day, especially between 7 a.m. and noon, there are longer trips, and also during evening rush hours between 5 p.m. and 8 p.m., there are a lot more trips as well that are of longer times. Another thing that you can do with this type of visualization is you can add a third variation called color or hue in this case. We're going to take the same code, but just adding on hue equals and say hue equals to user type. So we want to visualize whether subscribers take more trips than customers or vice versa, and this would allow you to do that. So we can see most of the really long trips, the outliers are by subscribers, and pass holders are taking shorter trips in general. Okay, so the second question we're going to answer here is what bike stations are most popular to start our trips from. We're going to visualize this in a map using folium. In order to visualize counts for different bike stations on a map, we have to first make a new data frame using the group by method to count how many trips were taking place from each station. We're going to group by start station ID. And name the new column counts. As you can see here, we now have a list of unique start station ID with how many times the trip started from that station ID on that day. We're going to make this a new data frame called df2. So df2 only has these two columns. We now need to reattach the station latitude and longitude as well as station name back to this column using the merge function in Pandas. Remember, the original data frame looks like this. We're going to drop columns. Since we don't want duplicated station latitude and longitude and name from the same station ID, this is why we're dropping duplicates by the column name start station ID. Okay, so now we have 328 rows, which match the number of unique station IDs that we have. We're going to name this temp. It's a temporary data frame. Next, we're going to perform a left join to data frame 2. We only want to keep certain columns from the temp data frame, and this is where we would subset the data. We're performing a left join here, and you indicate that through the how keyword, and we're joining it on the column start station ID. This is our data frame. We have 328 unique station ID, and we have counts for each station ID as well as their attributes, name, latitude, and longitude. We're going to make these the new data frame too. Okay, we're almost at the visualization stage. For visualization on the map, we need to use either GeoPandas or folium. In this case, we are downloading folium package. Next, we need to import this package. To initialize an empty map, we have to use the folium map function. For the centroid of the map, I'm going to just quickly get a random latitude and longitude from my dataset. Here. This is where the original empty map will be centered around. So this is a random station ID in New York City. This is what our map looks like. We have now created an empty folium map object centered around New York City with OpenStreetMap tiles in the background. Next, we're going to add our data points to this map as markers. We have to write a for loop for each of the data points. And to add these markers, use folium.circle. This is where we indicate where the latitude and longitude the data should be taken from. We want to have a pop-up information box showing the station name. And the radius is to show different sizes based on different counts. If a station has more trips, then the size of the circle on the map will be bigger than other stations with less trips. Color is red. And we want to add this to our map object that we have created above. So now if we want to look at the map again, it would look something like this. I really like Folium because it makes these maps interactive. So if you click on it, it's the pop-up that we set before, which is the name of the station. The size indicates the number of trips started from this station. This concludes the 2 questions for our project. Now a few words about our sponsor of this video. As you can see in this video, Anaconda provides a ready-to-code cloud Jupyter notebook environment that can get your hands on coding super quickly and super easily. In addition to the IDE, Anaconda also provides practical courses through the Anaconda Nucleus platform. Courses such as Jupyter Notebook Basics, Introduction to Python Programming, Introduction to Machine Learning, and Introduction to SQL should get you started quickly on the foundational knowledge you need to start your journey into data science. And now you can access all of these courses for free for 30 days with code Maggie. And last but not least, As data scientist, I use Anaconda every time I code as my go-to virtual environment that manages all my packages for different projects. If you've never used a virtual environment before, I definitely recommend starting this good practice right away. Using a virtual environment allows you to avoid installing Python packages globally, which could break system tools or other projects. I'm sure we've all been there before. And if you don't finish a project in one setting, a virtual environment saves all of your packages installations for you and can get you quickly started on your feet when you're ready to code again on that project. As for the future steps of this project, since the timestamp includes the exact hour, minute, and second, we can also sort data into groups and then run the same visualization that we did for question 2. For example, if we divide data by a few time slots, 7 to 10 a.m. as morning rush hours, 10 a.m. to 4 p.m. as daytime hour, 4 to 7 p.m. as evening rush hour, and 7 p.m. to 7 a.m. as off-peak hour. And then we can visualize using the code in this notebook whether people tend to pick up bikes from different stations based on different times of the day. And when you're done, you can also download this notebook from the Cloud IDE environment and add to your portfolio projects. If you're a student and don't know what topic to choose for your data science portfolio project, I also made a video on how you can turn your school assignments into portfolio projects to showcase your skills. I'll link it here. And if you like this video, don't forget to give it a thumbs up, subscribe, comment, and I'll see you in the next video. Bye.